Now I will derive an expression for speed of longitudinal waves in fluids. Sound waves are examples for longitudinal waves. Fluid is air medium. I will consider a tube whose area of cross section is A and two plane cross sections M and N, which are at pressure, density, velocities are P, rho, V, P1, rho 1, V1 respectively. V is velocity of sound. This is the direction of velocity, and say this is the direction of air. Now I will consider this is a compressed region and this is a rarefied region. Therefore density at this point is more than density at this point, and velocity is less at this point than this. So I can write rho 1 is greater than rho, V1 less than V. I will consider density, which is mass by volume, which is equal to mass by volume can be written as area into thickness. If time is 1 second, velocity is equal to thickness by time is equal to x by 1 is equal to x. So because we get V is equal to x, it is because m is equal to rho ax, and which is also equal to rho av. Now mass can be written as rho av. Call it as equation number 1. At section M, mass entering is rho av. At section N, mass exiting is rho 1 a v1. Average density of air is same. Therefore I can write rho av is equal to rho 1 a v1. Both are equal. Now this is equal to mass. A cancels with each other. I can write v1 by v is equal to rho by rho 1. Call it as equation number 2. Momentum at M is mv. Momentum at N is mv1. In 1 second, change in momentum is mv minus mv1. Call it as equation number 3. Now decrease in pressure is force by area. Now this can be implied that force is equal to decrease in pressure into area. Call it as equation number 4. Newton's second law says that force is equal to rate of change of momentum. This is equal to change in momentum if change in time is 1 second. Equation 3 and 4 are equal. Therefore I can write P1 minus P into A is equal to mv minus mv1, which is equal to mv into 1 minus v1 by v. Call it as equation number 5. Now you know that m is equal to rho av, v1 by v is equal to rho by a, which is already arrived at this section. Now you can write P1 minus P is equal to rho v square into 1 minus rho by rho 1. Rho v square is equal to P1 minus P divided by rho 1 minus rho divided by rho 1. Call it as equation number 6. Now we shall consider bulk modulus, which is defined as ratio of volume stress to volume strain. Volume stress is excess pressure by excess pressure, and volume strain is change in volume divided by original volume. This is equal to P1 minus P divided by V minus V1 divided by V. Why? Because stress is force by area. Here is force by area is pressure, which is the excess pressure, and change in volume is final volume minus initial volume. Now bulk modulus is rewritten as P1 minus P divided by rho 1 minus rho divided by rho 1. Call it as equation number 7. Now you know that density is equal to mass by volume. So rho is equal to m by v, rho 1 is m by v1. We consider the ratio v minus v1 by v. Replace v by m by rho, replace v1 by m by rho 1 and v by m by rho. Substitute and simplify this, you will get the ratio rho 1 minus rho divided by rho 1. Now therefore equation 6 and 7 are equal. You can write k is equal to P1 minus P divided by rho 1 minus rho divided by rho 1. Equation 6 and 7 are equal. Therefore you can write k is equal to rho v square. This implies that velocity is equal to square root of k by rho. Newton's formula. Newton assumed that when sound propagates through air medium, isothermal condition is possible, that is temperature remains constant. If temperature remains constant, K is equal to P, P is equal to rho GH. Why? Because rho is density of mercury and pressure is 1 atmospheric pressure. Substitute this, velocity is equal to density of mercury is 13,600 into G is 9.8 and H is 760 mm of mercury. Density of air is 1.293 kg per cubic meter. This is equal to 280 meter per second. But it has shown about 16% discrepancy than the experimentally observed value. Therefore, Laplace gave correction for this formula, which is popularly known as Newton-Laplace formula. For adiabatic process, K is equal to gamma P. Laplace assumed that when air propagate through sound propagate through air medium, isothermal condition is not possible, but adiabatic condition is possible. That is, there is no interchange of heat, but temperature does not remain constant. Now, for this case, V is equal to gamma P by rho, which is square root of 1.41 into 13,600 into 0.76 into 9.8 divided by 1.293, which is equal to 332 meter per second, which is in excellent agreement with the experimentally observed value. We can see the values observed. At 0 degrees Celsius, 331.5 meter per second. At 20 degrees Celsius, 343 meter per second. At 25 degrees Celsius, 346 meter per second. Therefore, the expression for speed of longitudinal waves in fluids is Newton-Laplace formula.